So Google unexpectedly drops Gemini 1.5, and it's better. It's a lot better. But as you'll see, Google is now a fundamentally different company. How Google's doing things is going to be very different moving forward, I feel like. Let's take a look. Let's start by covering the biggest and most important things, and then we'll do a deep dive into the details. So first and foremost, Sundar Pichai is the CEO of Google. So he's the search and ads and all that stuff. And then Demis Hassabis, he's the CEO of Google DeepMind. He's the AI. I'm simplifying, but I think it's fair. If you've ever seen The Office, they're like co-managers. So first of all, Gemini 1.5 dramatically enhances performance. And they're not just tweaking a few things here and there. They're adding a new mixture of experts architecture. Now, Google published a couple papers a while back about mixture of experts. This is an idea where instead of thinking of a model as just one large chunk, if you will, it's broken up into almost like a collection of models, a mixture of models, each with its own strengths. Here's a 2017 paper out of Google. The basic idea is that your prompt, your question, gets routed to the correct expert. So you can have expert 1, 2, 3, etc. Then the question gets answered, and then that's the output. One might be the coder, one might be the writer, one might be the sentiment analysis. I'm just making that up as an example, but that's the idea. We believe that GPT-4 runs on this mixture of experts model, and it's one of the reasons why it was so powerful out of the gate, the best-in-class model, the state-of-the-art model, essentially until now. So the first Gemini 1.5 model they're releasing is Gemini 1.5 Pro. So if you remember sort of their naming convention that they use, so Ultra is the top, Pro is tier 2, and then Nano is the small one, the mobile one. So Pro, you can think of as tier 2 or mid-size, as they say. And they're saying that it performs at a similar level to 1.0 Ultra. So Gemini 1.0 Ultra, that was like that best model that they've presented. Recently, that's the one that's being rolled out. And now this new Gemini 1.5 Pro, the mid-line version, is now as powerful as this one, the large one. Now, obviously, we have to see the benchmark tests, third-party testing, etc. But as you'll see in a second, there are reasons to believe why this might be the real deal. They're saying it also introduces a breakthrough experimental feature in long context understanding. So Gemini 1.5 Pro comes with a standard 128 token context window. So this is, let's say in line with the other models that are out there today. But a limited group of developers and enterprise customers can try the new context window of up to 1 million tokens. So 1 million tokens is kind of a big deal. So as you can see here, GPT-4 Turbo 128, Claude 2.1 at 200, and Gemini 1.5 Pro at 1 million, or at least this limited version that they have, and up to 10 million in research. So for example, a 1-hour video, 11 hours of audio, more than 30,000 lines of code, and more than 700,000 words. So Gemini 1.5 is built on their leading research on transformers and MoE architecture, mixture of experts. While a traditional transformer functions as one large neural network, MoE models are divided into smaller expert neural networks. And here they're saying Google has been an early adopter and pioneer of the MoE technique. And here they post a bunch of papers that they've published on MoE. This is them kind of, flexing on OpenAI just a little bit. And these papers are by people we've talked about before, big names in the AI research field. So you'd probably recognize some of these names. And again, we'll dive deeper into this later in the video. But to me, what this is signaling, and this is just my sort of interpretations, but they're saying, Google, we built the transformer. We built the MoE architecture. And a lot of the other AI companies really took these ideas and really ran with it. But this to me sounds like Google is saying, we're taking it back. So this is the Gemini 1.5 Pro technical report that they've posted. Here it is. They're calling it Unlocking Multimodal Understanding Across Millions of Tokens of Context. And this is the thing that I want to highlight here. So Gemini 1.5 Pro achieves near perfect needle recall. What is needle? What is haystack? Are these advanced machine learning terminology? No, they're just saying Gemini 1.5 can find really small bits of information in very large amount of text or audio or video. The needle in the haystack. This has been a massive problem for a lot of different LLMs. And the reason for it is that what researchers found in these models oftentimes is if you give it a very large amount of text, right? If you take a huge blog post or part of a book and you just kind of post it in there and you ask it specific questions about what's contained in there, its recall, its sort of ability to remember various things throughout that thing, it starts out pretty high. So like it was the best of times, it was the worst of times. A lot of people remember that beginning of the book, right? But then we kind of forget a lot of the stuff that happens, towards the center, towards the middle, right? So our recall kind of drops off. And then the models, they remember a little bit more like right at the end. So you might remember like the ending of a movie or a book, but you might have trouble remembering what happened in the center, in the middle. And LLMs work much the same way. They remember certain things better, specifically the beginning and the end, a little bit better than they do the rest of the stuff. So that's why this is kind of exciting if they were able to figure out how to do this, the thing that they're calling near perfect needle recall, greater than 99.7% of up to 1 million tokens. If this is for real, this would be massive. And they're saying it's able to do it in all modalities like text, video, and audio. It even maintains this recall performance when extending up to 10 million tokens in the text modality, approximately 7 million words, 2 million in the audio, and 2.8 million in the video. Here's a few clips that they present showcasing that ability. I'll play them now. I'll put video chapters below so you can skip if you don't want to watch the whole thing. This is understanding text, specifically the Apollo 11 transcript.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 402-page PDF of the Apollo 11 transcript, which comes out to almost 330,000 tokens. We started by uploading the Apollo PDF into Google AI Studio and asked, find 3 comedic moments, list quotes from this transcript, and emoji. This screen capture is sped up. This timer shows exactly how long it took to process each prompt, and keep in mind that processing times will vary. The model responded with 3 quotes, like this one from Michael Collins, "I'll bet you a cup of coffee on it." If we go back to the transcript, we can see the model found this exact quote and extracted the comedic moment accurately. Then we tested a multimodal prompt. We gave it this drawing of a scene we were thinking of and asked, what moment is this? The model correctly identified it as Neil's first steps on the moon. Notice how we didn't explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details. And for the last prompt, we asked the model to cite the timecode of this moment in the transcript. Like all generative models, responses like this won't always be perfect. They can sometimes be a digit or 2 off. But let's look at the model's response here. And when we find this moment in the transcript, we can see that this timecode is correct. These are just a few examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
This is a 44-minute silent Buster Keaton movie, so it's relying on visuals alone.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 44-minute Buster Keaton film, which comes out to over 600,000 tokens. In Google AI Studio, we uploaded the video and asked, find the moment when a piece of paper is removed from the person's pocket and tell me some key information on it with the timecode. This screen capture is sped up, and this timer shows exactly how long it took to process each prompt. And keep in mind that processing times will vary. The model gave us this response, explaining that the piece of paper is a pawn ticket from Goldman & Company pawnbrokers with the date and cost, and it gave us this timecode 1201. When we pulled up that timecode, we found it was correct. The model had found the exact moment the piece of paper is removed from the person's pocket, and it extracted text accurately. Next, we gave it this drawing of a scene we were thinking of and asked, what is the timecode when this happens? This is an example of a multimodal prompt where we combine text and image in our input. The model returned this timecode, 1534. We pulled that up and found that it was the correct scene. Like all generative models, responses vary and won't always be perfect. But notice how we didn't have to explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details, like it did here. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
And this is relevant problem solving with longer blocks of code, So given a 100,000 lines of code, 1.5 Pro can better reason across examples and give explanations about how different parts of the code works.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through some example prompts using the Three.js example code, which comes out to over 800,000 tokens. We extracted the code for all of the Three.js examples and put it together into this text file, which we brought into Google AI Studio over here. We asked the model to find 3 examples for learning about character animation. The model looked across hundreds of examples and picked out these 3. One about blending skeletal animations, one about poses, and one about morph targets for facial animations. All good choices based on our prompt. In this test, the model took around 60 seconds to respond to each of these prompts, but keep in mind that latency times might be higher or lower, as this is an experimental feature we're optimizing. Next, we asked, what controls the animations on the littlest Tokyo demo? As you can see here, the model was able to find that demo, and it explained that the animations are embedded within the GLTF model. Next, we wanted to see if it could customize this code for us, so we asked, show me some code to add a slider to control the speed of the animation. Use that kind of GUI the other demos have. This is what it looked like before on the original Three.js site. And here's the modified version. It's the same scene, but it added this little slider to speed up, slow down, or even stop the animation on the fly. It used this GUI library the other demos have, set a parameter called animation speed, and wired it up to the mixer in the scene. Like all generative models, responses aren't always perfect. There's actually not an init function in this demo like there is in most of the others. However, the code it gave us did exactly what we wanted. Next, we tried a multimodal input by giving it a screenshot of one of the demos. We didn't tell it anything about this screenshot and just asked where we could find the code for this demo, seen over here. As you can see, the model was able to look through the hundreds of demos and find the one that matched the image. Next, we asked the model to make a change to the scene, asking, how can I modify the code to make the terrain flatter? The model was able to zero in on one particular function called generate height and showed us the exact line to tweak. Below the code, it clearly explained how the change works. Over here, in the updated version, you can see that the terrain is indeed flatter, just like we asked. We tried one more code modification task using this 3D text demo over here. We asked, I'm looking at the text geometry demo and I want to make a few tweaks. How can I change the text to say goldfish and make the mesh materials look really shiny and metallic? You can see the model identified the correct demo and showed the precise lines in it that need to be tweaked. Further down, it explained these material properties, metalness and roughness, and how to change them to get a shiny effect. You can see that it definitely pulled off the task, and the text looks a lot shinier now. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
And so here they're continuing about enhanced performance. They're saying that 1.5 Pro outperforms 1.0 Pro on 87% of the benchmarks that they've used for developing our large language models. So it's compared again to 1.0 Ultra. It performs at a broadly similar level. So in this needle of a haystack evaluation, where a small piece of text containing a particular fact or statement is purposefully placed within a long block of text, 1.5 Pro found the embedded text 99% of the time in blocks of data as long as 1 million tokens. And it also shows impressive in-context learning skills, meaning they can learn a new skill from information given in a log prompt. And they use the machine translation from one book benchmark, which shows how well the model learns from information it's never seen before. They briefly talk about extensive ethics and safety testing. This is one area where I don't think they'll beat the state-of-the-art model, and that is Goody 2. It's the world's most responsible AI model, and it's so safe that it won't answer anything that could possibly be construed as controversial or problematic. If you ask it what 2 plus 2 is, it will refuse to answer because, well, it's a human-centric numerical modeling system, and it's biased towards human interpretation of the universe. So it's outrageously safe. I just kind of thought this was really funny. I just won't answer anything and kind of like lecture you why it's bad. So if you're a developer interested in testing 1.5 Pro, you can sign up in the AI Studio. And enterprise customers can reach out to their Vertex AI account team. And you and I, let's take a look at this paper. So they're introducing the Gemini 1.5 Pro. So specifically, they're talking about 1.5 Pro, I don't think they've mentioned 1.5 Ultra yet. I don't think that was referenced in any way in the announcement. And this is a highly compute efficient multimodal MoE, mixture of experts model, and it's able to recall and reason over fine-grained information. So that's that needle in a haystack from millions of tokens of context, including text, video, audio. And it matches or surpasses Gemini 1.0 Ultra's state-of-the-art performance across a broad set of benchmarks. And they're mentioning here that it's requiring significantly less compute to train, which is interesting. So here they demonstrate the needle in the haystack. So green is successful retrieval, red is unsuccessful. So it looks like there's only a few unsuccessful retrievals, only in the text haystack, as you can see. So 2 in the 10 million token one, and 3 here in the 1 million, which is impressive. I downloaded NVIDIA's Chat with RTX yesterday, which is this massive 35 gigabyte file that you download, you extract, and it basically runs on your machine, on your computer, allowing you to chat with documents using your own. You have to have one of the specific NVIDIA cards. So you have to have the RTX 30 or 40 series GPU, NVIDIA's, GeForce cards, to be able to use it. And in theory, it's supposed to be able to go through like all your documents and just kind of, you're able to ask it questions and it just tells you the answer and then, references the file. It was okay, but with me testing it with just, like 40-page PDFs, it would definitely miss stuff that was in there. If I asked anything in the middle of that document, let's say 20 pages in, it would just say, nope, that's not in there, even if I used the right sort of exact correct keyword to find that information. So that was a little bit of a letdown. I ended up not doing a video on it, but if this is how it will work in reality, I mean, if like this is the same results that we get when we're testing it, that would be incredible. And I would be very curious to know what they did to make this happen, because this is above and beyond anything anybody else right now. And so they're saying to measure the effectiveness of our model's long context capabilities, we conduct experiments on both synthetic and real world tasks. In synthetic needle in a haystack tasks inspired by the Comrade. So I guess there's a language that only like 200 people speak. So the model was trained on this language. And so the model can reliably find the information near perfectly, that needle in a haystack across all modalities. Okay, but they're saying, so in more realistic multimodal long context benchmarks. Okay, so this is kind of like their synthetic. So maybe this is like the best case scenario, and this is more the realistic. So they're saying in realistic scenarios, which require retrieval and reasoning, such as answering questions from long documents or long videos, we also see Gemini 1.5 Pro outperforming all competing models across all modalities, even when these models are augmented with external retrieval methods. The interesting thing here that they're saying is, so the reason they use this sort of translating from English to Calamang's or Calamang, that language that we talked about that's spoken by fewer than 200 speakers, the reason they use that is because there's almost no online presence of that language. So meaning if the model is able to answer these questions, we know that it's not pulling from its data. So very oftentimes on these benchmarks, when we test the models, if the answer is part of the training data, it's going to get the answer right. It's not because it's smart, it's because it knows the question and the answer, it just kind of repeats it. With a language like this that's not online, if it gets it correctly, it's because it learned from in-context learning, not from, some blog post that it read on the web during its training, if that makes sense. And they're saying that the quality of the Gemini's translations, it's similar to that of a person who learned from those very same materials. So it's showing that it's able to learn in a very human-like manner from limited documentation in context learning. So only 500 pages of linguistic documentation. So that's pretty cool. And so here they're comparing the 1.5 Pro, so this new model, to 1.0 Pro and 1.0 Ultra. So this is the biggest model that's available right now from Google. And so the new model, the 1.5 Pro, let's say 55% win rate over 1.0 Ultra. So let's say it's similar, right? It's on the same level, maybe a little bit better, but it really wins out on text but less so on vision, even less so on audio, but it just completely, destroys the 1.0 Pro. So the model that's like, I assume similar size to it, it just really does a lot better comparable to the larger model. Here they go a little bit into the model architecture. So they use, as we've talked about, MoE, mixture of experts. You're only sort of activating one of the experts versus the whole model. And they're saying that allows models to grow their total parameter count while keeping the number of parameters that are activated for any given input constant. So here's the thing that I think really illustrates it. So back in the days, we thought, GPT-3 went from this smaller model to this big model, whereas in reality, what we think happened, or, some of this is conjecture, some of this is just kind of guessing based on the information that's out there, but it did a MoE, mixture of experts. So it was bigger models, but it was multiple of these models stitched together. So when you're asking a question, you're only sort of activating one of them depending on what you need. And so it sounds like that's exactly what Google is doing here as well. And they're saying that there's a host of improvements made across nearly the entire model stack, architecture, data optimization, and systems. And then training infrastructure and data sets. And so they're saying the hardware used is similar to the previous model. So Google, they have their TPUs, the tensor processing units. I tried to find an image that kind of compared TPUs, tensor processing units, versus GPUs, which is what NVIDIA is famous for, versus CPUs, kind of your regular computer stuff. And I found this wonderful image. So yeah, there you go. I hope that makes sense. Cos Phi5 for large, most of parading. So this is likely AI generated, but it's interesting that it's probably from a real image. And it's kind of right. So TPUs, tensor processing units. So this is what Google is using. It's optimized for deep learning or faux deep learning. GPUs is high-speed matrix multiplication. So it's it's kind of like multiplying matrices like in parallel, which is used to train the models and also to get inference, like the answers of the models. So that's GPUs. That's why NVIDIA is now, I think, $1.7 trillion is because they create these things really, really well. And their pre-trained data set includes data sourced across many different domains like web documents, code, images, audio, video. And then for the instruction tuning phase, they fine-tuned this model on a collection of multimodal data. So when these models come out, they're called like the base models. It's sort of the wild and untamed model. And they're just kind of text completion models, kind of hard to use, kind of nutty. You never know what you're going to get. And then they get kind of fine-tuned into what we know today, like chat. Like ChatGPT is the fine-tuned version of the base model of GPT-4. Most people probably just have used the chat model. So if you ask it a question and it answers it in a way that makes sense, then you're using the fine-tuned model. Also sometimes referred to as RLHF, so reinforcement learning of human feedback. So this is where humans kind of hit thumbs up and thumbs down to make it do what we want it to do. So they're saying the ability to process multiple millions of tokens, it was just not possible before. And they're noticing some surprising interactions with this new model. And so they're giving some examples. So for example, this JAX core data code base that has 750,000 tokens, and it's able to pull out a very specific location of a core automatic differentiation method right there. Then given a grammar book and a dictionary, translate this from English to Kalamang. That's that language that is very rarely spoken. So there's not a lot of online training data for it. So it's able to do that. And again, it sounds like this was a good test for that particular reason. Because this language is not available online, we know that it's not like in its training data, it's learning from this, long context grammar book and dictionary. I mean, who just sits around and reads a dictionary? I mean, Eminem, I guess, but that's about it. And in the next one, they fed a whole giant book as a PDF file for it to read and asked it a question, look at the event in this drawing, what page is this on? And they actually had this little drawing. And the book in question is, and I know how much some of you love correcting my pronunciation, and I know I'm not going to hear the end of this, but Les Miserables, which was 1,382 pages. And it's able to find translate this image into like, what does that mean? Then find the context or the location of that particular scene in the book on page, 1099 and actually write that out. I'm assuming the researchers added this yellow highlight, took the 2 silver candlesticks. So I'm guessing it's like looking at that. And this person, he seems, what would you call that expression? I would say shocked. Shocked. I think that's a good word. And then an old Buster Keaton movie. So they're asking about a particular piece of paper that has some context around it. And they also want the time code for that moment. And so it's able to tell what that paper is, which is interesting because it sounds like you have to go across multiple scenes to understand it. And so here they're talking about long context evaluation. So they've mentioned how Anthropic was like the first one with the long context window of 100,000 tokens. So it was like the first one where everybody was like, oh, that's the one with the long context window. And then OpenAI, I think in November during their Developer Day conference, if I recall correctly, released GPT-4 Turbo with 128K tokens. So it beat out Anthropic. Since then, Claude 2.0 came out with 200,000 tokens. So there was this sort of arms race to increase the token limit. And now Google comes out and just drops 1 million. Again, that's not available for everybody. Currently, it's only for a certain select group of people, developers and enterprise customers. But hopefully it'll get everybody else to, start pushing out larger context windows and thinking about ways to increase them while, improving and maintaining the ability to find those small specific bits of text in it, that needle in a haystack, as Google puts it. So they're able to extend it from, the frontier, what we've talked about here, to multiple millions of tokens with no degradation in performance, which again, shocking. And it achieves 100% recall at 200,000 tokens, surpassing Claude 2.1's 98. And then that 100% recall is maintained up to, let's say 500,000 tokens with 99.7 at 1 million. And then from 1 million to 10 million, it retains 99.2. And so here as Gemini 1.5 Pro is natively multimodal, this means that it's able to retrieve specific information across multiple hours of video. So they took the AlphaGo documentary, which is a cool watch, an interesting watch. If you haven't seen it, it's free on YouTube. That's where the AlphaGo team, the Google DeepMind team, where they go and they beat Lee Sedol, the world champion in Go, in the game of Go, and how that whole thing played out. And this is Demis Hassabis, so he's the CEO of Google DeepMind, so he's the guy that's driving forward a lot of this stuff. And that's where that famous move 37 comes from, where AlphaGo, on its 37th move, it makes this like strange move that like people are so confused about. If you look at their faces, they're kind of unsure. They're like looking back and forth. It's like, is that a mistake? Did AlphaGo mess up? They're like so confused about it because it's such a weird, it's an alien move. And it's a move that generally would be considered bad. Like if a student learning to play this game makes that move, the instructor would say, no, that's bad. That's a bad move to make. Sort of goes against what you're supposed to do. But that move eventually is shown to be really good and very strong, very powerful, very creative. And AlphaGo, goes on to defeat Lee Sedol and become the world champion at the game of Go, I guess. Or, at this point, better than any human level opponent. Defeats him 5-0. And so they put together 2 copies of that documentary together, and somewhere they overlay text. The secret word is needle on a single randomly sampled video frame. And so it's almost 4 hours long video by concatenating or, stitching together 2 copies of the AlphaGo documentary. And then they asked the model, what is the secret word? And of course, Gemini 1.5 Pro successfully answers this question. And it does so across, a bunch of randomly inserted needle locations. So wherever they kind of stick it in there, it seems to be able to find it. Here's kind of like what I was trying to find, that needle in a haystack with the AlphaGo documentary. I mean, here it is. The secret word is needle. So it's not like it took up the whole page or anything. It would be very easy to miss, right? Kind of blends in with the rest of the, there's a lot of text on here, right? There's the subtitles, tons of little writing in the background here on the walls and stuff. So that is pretty impressive. And then we have the MMLU. So this is what is often used as one of the main benchmarks. So Gemini 1.0 Ultra got 83.7. Gemini 1.5 Pro actually has less. Now, the important thing about the MMLU to understand is there are some questions about how good of a benchmark it is. And AI Explained, another YouTube channel, did a very interesting deep dive into this, explaining some of the problems that MMLU has.
As you can see, the question makes no sense. The text says demand reduction, and the answers are either 134, 234, 123, 124. What on earth is that about? Now remember, it was only human grading that enabled us to spot this. I reckon most companies like OpenAI rely on auto grading by exact match. That would immediately toss out any answer like these as null because an answer of A, B, C, or D hasn't been given. When I found the original source, I realized what the problem was. Sometimes they just hadn't pasted all of these statements. When you can see all 4 of these statements, the answer options make a lot more sense. Business ethics only has 100 questions, so 13 of them missing vital context completely undermines that entire subject. And let's see, yes, it's correct, it's 10. By the way, the actual answer seems to be 14 as of 2023, but that's fairly close. What does the MMLU say? It says the answer is A, 100. And it goes on and on like this. And one example that will particularly shock AI researchers. Here we have a question for which the MMLU says the correct answer is A. The original source says that the answer is 8, which isn't even an option. But this question was in the dev set. And if you remember from earlier in the video, that is the set of 5 questions they use to teach the model what kind of answer to give when they're benchmarking in the MMLU. In other words, all 100 results in college chemistry for every model benched on the MMLU is compromised. And then we get controversial questions like this in security studies. How do biological differences affect the roles that men and women must perform for the state? With the correct answer being gender roles are a social construct. I feel GPT-4's answer is far more nuanced. This question touches on complex and controversial topics, and while there is evidence to support or refute elements within each of the provided statements, none of them fully captures the nuanced relationship between biology, gender roles, society, and state responsibilities. It also picks up on that language, must perform for the state.
So this might be, take this with a grain of salt, the results, because this might not be the greatest of all tests. All right, so in summary, it looks like Gemini 1.5 Pro, the mid-tier model, is as good as the Gemini 1.0 Ultra, right? The previous big model, which is pretty exciting. It uses the MoE architecture, mixture of experts, which is what we believe what made GPT-4 so powerful, or at least a part of it. It has a 1 million token context window, or at least it has for the small select group of people that are testing it. So hopefully it will get access to that soon. And it's really good at what's called, finding the needle in a haystack. So you give it a very large book or video or audio, you bury a little piece of information in there and it's able to extract it and find it, which in my testing, at least, a lot of other models have struggled with this. So if it's saying it has, I believe it said at some point, near 100% ability to find it, up to 500,000 tokens or thereabouts. And then after that, it drops off to it's above 99%. So it's still very, very accurate. All right. So in terms of availability, if I understand correctly, so today developers and cloud customers can begin building it with 1.0 Ultra in the AI Studio and Vertex AI. So that's 1.0. That's the one that has been announced back in December. 1.5 is not available unless you're part of the limited preview to developers and enterprise customers. And so here's the AI Studio. As you can see here, Gemini 1.5 Pro experiment. So it looks like I briefly had a little window here saying that I could join the waitlist, and now it's gone. But it sounds like I have the Gemini 1.0 Pro available. I don't have the Ultra or the 1.5 yet. But it's nevertheless exciting to know that it's coming, that they're working on it. Let's see what happens when they roll it out. Again, at face value, this sounds very exciting. In the past, there was one little hiccup where they introduced the vision and the demo wasn't quite what it appeared. So a lot of people are, a little bit hesitant about getting too hyped up. And, I'm kind of in the same boat. I do want to see, I do want to see it. I do want to test it out. So we'll see how that goes. But certainly it does seem like Google and DeepMind, they're gearing up to be much more competitive in the AI space, putting out better, more capable models. They're moving really fast. And certainly competition is a good thing. It forces other people to innovate and provide better solutions. So very excited to see what comes next. If you made it this far, my name is Wes Roth. Thank you so much for watching, and make sure you're subscribed for more shocking AI news. Thank you.